Hello everyone, welcome. In the previous video, I promised that I would go straight to rules of differentiation. However, I've decided to bring in one more example on first principles to make sure that you thoroughly understand the idea of first principles. So here is a question, which is a typical exam question. In fact, it's a past exam question. You are told that f of a is equal to ax squared plus bx plus c. And then we're required to determine f prime of a from first principles. Notice now that if you are given an expression like this and you're told this is f of a, it means the only variable you're supposed to focus on is a. Everything else must be treated as a constant. So in other words, x is a constant, b is a constant, and c is a constant. The only variable is a. All right, so let's go through this then. Our solution is as follows. We know that f of a is equal to ax squared plus bx plus c, and therefore f of a plus h will be equal to a plus h x squared plus bx plus c. Remember now, it's only a that's affected. So in the place of a, I now have to put a plus h like this. Simplifying this, we get ax squared plus hx squared plus bx plus c. Right, let's go straight to the formula now. F prime of a, the formula says this is equal to limit as h approaches 0 of f of a plus h minus f of a all over h. Substituting these two expressions into the formula, we're going to have limit as h approaches 0 of ax squared plus hx squared plus bx plus c minus open brackets. Remember I told you, you must always use brackets here. Always use brackets here. So we have ax squared plus bx plus c. And we're saying all over h. Right, next, this is equal to limit as h approaches 0 of ax squared plus hx squared plus bx plus c minus ax squared minus bx minus c all over h. Cancelling these terms here, in the numerator we have hx squared only. So this is equal to limit as h approaches 0 of hx squared all over h. Cancelling the h, we have limit as h approaches 0 of x squared, which in fact is equal to x squared. So this is your final solution. This question in the previous exam, it was not very well answered by most students, because most students are used to having x there, and so they were substituting a plus h in the place of x instead of only in the place of a. So please take note of this. All right, I am going to stop here in this short video. My next video is going to be on rules of differentiation. I'm going to prove a couple of them there, and my intention is to go through all the rules and then look at examples on differentiation by using rules of differentiation. And then we'll end up with applications of differential calculus. That will be the end of this topic as far as grade 12 work is concerned. But if you are in first year and second year, I'll move further to integration. Right, I'll see you next time.